I am Debashish Mishra and my next topic is decision tree in machine learning. A decision tree is a supervised learning algorithm used for classification and regression tasks. It works by splitting data into branches based on features value, forming a clear tree-like structure. Each split aims to improve prediction using metrics like Gini impurity, entropy, and MSE. The tree ends in leaf node that provide final output. Decision trees are simple, interpretable, and require minimal pre-processing, but they can easily overfit without pruning or depth control. This is the structure of decision tree. To implement decision tree, I imported some of the required library files. This is the library file I imported. Here I use pandas library to store and manage the data in tabular format. Next, I import train set split to divide the dataset into training and testing set. I also import accuracy score, confusion matrix, and classification report from sklearn matrix to evaluate model performance. This is all the library files I imported. After that, a iris iris variable is created and iris is equal to load.iris function. Load a built-in dataset commonly used for classification tasks. X holds the feature data returned by the dataset and Y contains the target label, which in this case represent the flower species. I print them to observe the structure and format of the data. I print X and print Y to observe the structure of the data. After that, this iris feature name I print and it shows sepal length, sepal width, petal length, and petal width. These all are the flower species. The above command allows us to view all the columns present in the important dataset. For example, in this case, the dataset includes features such as the length, width of the sepal and petal. Next, I create a table from a iris dataset using the data frame function from the pandas library. Here, data variable is created and from panda a data frame is created and this is the dataset. The column in this table are the same of the one mentioned earlier. Then I do the min max scalar is used to normalize all the feature value in common range, typically 0 to 1, ensuring that each feature is treated equally by the model. I first create the scalar variable and then apply it to the data. After scaling, I create the dataset into training and test set using 80 to 20 ratio for training and testing respectively, which means 80% in training and 20% in testing. After scaling, I split the dataset into training and testing set. I do decision tree. I call the decision tree and fit the polished data into the model. This is the code. Next, I generate a confusion matrix using predicted and actual value to understand how accurately the model performs. It shows the number of corrected and incorrect classification. This is the final output which show how decision tree work. Conclusion. Decision tree are a great starting point of every learning mechanism. machine learning. They are simple to build, easy to understand, and give clear results you can actually explain. In our Iris example, we saw how scaling, splitting, and fitting the model leads to solid predictions, while tools like the confusion matrix show exactly where the model gets things right or wrong. The main thing to remind decision tree can overfit if left unchecked, so pruning or limiting depth in key still they are an excellent way to learn the basics.